Okay, let's look at a quick problem involving flow of people into and out of an amusement park. We're given the following information. First of all, that people are entering the park at the rate as shown on this graph. People are leaving the park is modeled by this equation that we see down here on the right-hand side. And at noon, there are 3,000 people in the park. And the question is, how many people in the park at 6 p.m.? So let's take a look. Well, people in the park at 6 p.m. is obviously people in the park at noon, plus the people that entered minus the people that left. So, how do we know how many people entered between noon and 6 p.m.? Well, we know that the integral of the entering function is just the area under this curve that we have over here to the right, the green plus the blue plus the red. And without going into details, what we've got is we've got that a total of 3,200 people entered. We have two trapezoids and a rectangle. So we now have 3,000 plus 3,200 minus, well, leaving is a little more complicated because for any given small interval of time, the height of the rectangle, the number of people who leave, will be the function at some time in that interval. And so, in order to get the total number of people that leave, we have to take the sum of all of those individual rectangles. We know, therefore, that that means the integral from noon, we'll call that time 0 to 6 of L of t dt. And plugging that into our calculator, what we get is that approximately 2,106 people left in that interval, leaving a total of 4,094 people in the park. And in this kind of business, we generally round to the nearest hundred because the question is not how many to the one, but roughly how many people are in the park. So we'll call that approximately 4,100 people in the park at noon. All right. So go ahead and do, those of you in my class, exercise 23 out of the book. And we will see you back here for the next video, which will be about pumping gas. Thanks for watching.